Welcome to the Learning Pines YouTube. We hope this video helps.
You begin by locking in the noble gas core, find the element's atomic number, and then pick the nearest lower noble gas, for example Ni or R. Once done, write that bracketed symbol first to replace filled inner shells, because this simplifies the configuration and highlights valence electrons. Make sure to keep the order of shells, 1s, 2s, 2p, 3s, 3p, and so on. Now move to the outer electrons. Those are what you'll add after the noble gas core. Next, you calculate how many electrons remain beyond the noble gas core. Subtract the core's electrons from the element's atomic number to get that count. Then add orbitals in correct sequence, n and subshell order. For transition, metals include d after the appropriate s. While adding, follow Hund's rule and the Pauli exclusion principle, so electrons pair only after each orbital in a subshell has one. Once you reach the remaining electron count, stop. That completes the shorthand configuration. Finally, verify the shorthand adds up to the element's atomic number. Recount electrons in the noble gas core plus the orbitals you listed. If numbers mismatch, reassess orbital order and electron count. Be aware of common exceptions. Chromium and copper shift one electron between s and d orbitals for stability, so adjust when needed. If you run into odd results, reapply Hund's rule and check energy ordering. That single troubleshooting tip will fix most errors and let you use the configuration to predict reactivity and bonding.
Thanks for watching. Consider subscribing if we helped you.